how to create symbolic objects, expressions, then changing the form of an existing symbolic expression, solving algebraic equations, differentiation in symbolic differentiation, symbolic integrations, and then we will try to look at few applications applied. One is on bending resistance of a rectangular beam, firing angle of a projectile using symbolic, and slider crank mechanism, covering both analytical and symbolic approaches to get solutions to this problem. So basically the content I'm just sharing, in fact, I've just taken a few clips from the book on MATLAB by An Introduction with Applications by Amos Gillard, which we have been widely using. And of course, some of the problems can be there from MATLAB and Introduction with Application with Dukkapati also. So coming to the introduction part, we have, so far we have just looked into some of the programs. We generally give you the output as a numerical value, okay? And numbers in terms of, you're dealing it in terms of numbers. So if you enter 1/4 in MATLAB, it gives you 0.25, or typing 2.3 gives you 0.667 as an approximate value. But there are a lot of applications in engineering which should be operated in terms of mathematical expression. Suppose I have an expression of ax plus b, then I would like to solve this equation in term for b in terms of the other for x in terms of the other coefficients b and a. Then I should have got it like this. So there is no numbers here. You would like to look at these expressions under the topic of symbolic maths. Okay, remember, when you carry out symbolic operations, there's no approximation of numerical values. So when you define x as a symbol in the package and you say what is 1/x/3 plus x/4, it will say 7/12x and not 0.5833x. Okay, it's not going to do any approximation. And directly coming to the content of this topic today, you can define a symbolic object, can be a variable, remember. It can be a number or it can be an expression. Okay, so just try to look at this, creating symbolic objects. I told you symbolic objects can be variables or numbers. They can be created by using sim command or sims command if you have a number of objects to be defined. And it can be, remember, the string can be a single letter, or it could be a combination of letters without any gap. It could be no spaces. You can also use a combination of letters and numbers. Try to look at this example. If you just, if those who have got facility on MATLAB can just type this command. Put the command here, a is equal to sim of a. And remember, this is in quote. And when you enter this and enter this in MATLAB command window, you'll get the display here. A is equal to a. Okay. Now, what is important for you is when you define something as a symbol, the output is not indented. So that means it will not have any space in the output. But if you type a number, remember, it will give you some space before in the display. So it is, first of all, it is not indented. And you can also use this command to define number of variables in a single line, like saying sims of yzd or sims of xw, xh, wydt, and so on. So to just have a better understanding, let us try to go through some of the examples. I hope you people have this Word file with you. You can just try to, code is there as example 1a. You just enter a is equal to sim of 3 and b is equal to sim of 5. And can you tell me what is the, when you enter it, and then define, create an expression, e is equal to b by a plus square root of 2. Okay. When you do that, you will notice that the output is in this form, 2 under square root plus 5 by 3. Okay. Remember, it is not approximating. It is in terms of fraction only. And when you want to convert this into a number, you can use the command called double. I'm introducing one important command. Whenever you would like to get the numerical equivalent of this symbolic term, of course, if you have assigned some values, automatically you can get the evaluated. So you can just try this command. Just type a sim of 3, b is equal to sim of 5, and e is equal to b by a plus square root of 2. And you say e value is given by double of e. See, this command double of e is very, very important. We are going to use it later. This can be used to convert the symbolic expression that is written in exact form to numerical form. That's a very important thing that you need to observe. Only when you say double of that, you will be getting the value associated with that number. Okay, this is one example. If I'm moving fast, you can let me know. Otherwise, these are all simple things which you can just directly type it in the command window and just get the results. Suppose you say C is equal to 3 and D is equal to 5. And say F is equal to D by C plus square root of 2. It creates an expression and immediately you'll get the output. Now just observe the difference here between these two. Here, when I say out, when I gave this command for E is equal to B by A plus square root of 2, I got this output and there was no gap here. This is not indented. Okay, but when you give it as a number, the same thing, but only thing is I've called C is equal to 3, D is equal to 5. So same 3 and 5 combination. And if you say the same expression, but in terms of A and B, I replaced it as D by C. You apply this and C, immediately you get the number. And remember, this is indented. There's a gap here. That's how you can differentiate in the output. Is it a symbol or not? Okay. If you're not getting the indented one, it is displayed as a symbol. Okay. Next, we'll try to look at some more example to have some more better understanding of this. Suppose you try to take this code. Of course, for every code, as Professor Narari said, clear and CLC is a very important thing. It's better to clear all those things in the database. Now, X is defined as symbol 5 here. Okay, X is defined as symbol 5. And when you say B is equal to X by 3 plus X by 4, the output will be, see this, 5 by 3 plus 5 by 4, and that will become 35 by 12. Still, it is not a number. It is indented. It is not indented. It's a symbol. Whereas, when you say double of B, that means you would like to evaluate this value because you assigned X is equal to 5 number, then you will see the output as 2.917. Okay, so D is equal to double of B will give you this value of 2.9167. But if you have done it without taking the symbolic definition by saying Y is equal to 5 and type the same equation, similar exact analogous equation, C is equal to Y by 3 plus Y by 4, you would have got the output as 2.916. Here you can see it is indented. Some gap is coming into picture, whereas here there is no gap. This part B is a symbol. Okay. Next, several symbolic variables can be created in one command by using the sims command, like putting sims command here like this. You can say sims y, z, d, and 2. Now remember, I told you the symbolic variables can be even a number also. So by putting it like this, you are defining y, z, d, and 2 as symbolic variables. And therefore, when you write an expression for this, E is equal to y by z plus square root of 2. See, square root of 2 will come first, and of course, y by z will come later. And this is the output, and there is no indentation here. So this E is also a symbolic, automatically will become a symbolic variable. But on the other hand, okay, just see the difference here. I've taken the same code actually and pasted it again, but you need to observe an important difference. Of course, clear and CLC are there. Here, the difference between this is YZD2 here, whereas here it is YZD comma 2. But by doing this, if you put a comma here, you are not defining 2 as a symbolic variable. This is actually YZ and D, not 2 as symbolic, but 2 is not going to be defined as a symbol. It still continues to be a number. So it is not defined here because you have separated by comma. And when you type it, you get this expression. Remember, 2 is not a symbol here, and you want to get the value of this, you need to use the double command. Okay. You can also think of creating symbolic expressions. Earlier versions had some facilities like creating a symbolic expressions directly. I think recently they would like to move out of this. Here, I'll come to this point later, I think. See this, there was facility if you try to define S as symbolic of sign of X plus Z, then earlier versions it was accepting, now there's a problem. So what you should do is you should try to define it as sign of sim of X plus Z, That means it is better you define x and z as symbolic variables by using the sim command, and then say s is equal to sine of x plus z. That's a better way to do it. Whereas earlier version, you could have also defined this expression itself as a symbolic variable. Remember, when you define this expression as a symbolic variable, and you would like to differentiate this expression with respect to x, if you have not defined x as a symbolic variable, then it is not possible to differentiate. Okay, so f is overall a symbolic variable, but the problem is you have not defined the elements of this as symbolic variable, and therefore it will not be able to differentiate. Also, one more thing is, if you look at this part, okay, here he has defined, you can define all these variables. Expression is this is sims of a, b, x, y, and then better define f is equal to ax square plus bx plus c, and you'll get the output of this. And I told you, if by chance if you have not defined any of this content, then it is not possible for you to differentiate. Try to look at this code by cutting and pasting. I might have done some mistakes here. I can correct it and send the PDF later. I'll just put the draft to the WhatsApp group also. See, observe this. This is defined as sims of x, y, abc. Okay, so this is not this way. It defines x, y, a, b, and c are defined as symbolic variables. Then, if you try to define this way, it is better. But if you try to define, I told you this is not acceptable, leads to error. If you define it as sine of sim of x plus y, then it will accept it. You can just try to look at this commands and explore this. But one command that I would like you to look at here is this command called expand. So when you define m as sine of x plus y, okay, and when you say expand, the output will be this way. It will expand. Remember, it uses the trigonometric identities formula and even other formulas of exponential and logarithmic, and we give you the output. So therefore, when you use the word expand, remember, sine of a plus b becomes sine a cos b plus cos a sine b, or sine of a minus b will be all the expansions can be obtained here. Okay, so I'm introducing you one more command after this double command is the expand command. Okay. Now, this is now not advisable to go by this way. Earlier textbooks had recommended this way. It is better to define, I told you, a, x, b as symbolic variable and also c, and then write the expression. Automatically, f will become symbolic. Now, existing symbolic expressions can be used to create new symbolic expressions. Okay, and this is when simply naming using the existing. For example, when you define here, this is sims of x and y. When you say SA is equal to x plus y and SB is equal to x minus 1, and when you say what is SA, it gives you x plus y, which is another symbolic variable. Okay, and similarly SB. So if you try to write what is there for f is equal to SA square plus divided by SB cube, that is, they would like to write this formula, you would have got this expression would give you this output. Okay, now let us try to look at some exercises here and run through this part. Just say clear all and clear C, and we have defined sims of x and y. So when you say SA is equal to x plus y and say what is SA, the output will be x plus y. If you say SB is equal to x minus y, remember x and y are already defined as symbolic variables, so you will get x minus y. So when you say SC is equal to SA into SB, remember it is x plus y into x minus y. But if you say expand, automatically these expressions each is multiplied and you get the final form. You know, a plus b into a minus b is a square minus b square. On the same way, therefore, x plus y into x minus y will be x square minus y square. Okay, that means expand command will give you the expanded version of this. Slightly moving ahead of this, if you see now xt is equal to x square plus y square, automatically you could have got this as x square plus y square as the output. And now you say SC is equal to SC into SD. SC is, remember, x square plus y square. And when I multiply it by x square plus y square into x square minus y square, automatically you will say, and what is SC? You can see it here. It is not the expanded form. By using this expanded form, what is again that we have done it is x square plus y square into x square minus y square. Therefore, it will become x to the power of 4 minus y to the power of 4. So start looking at the use of expand command. And furthermore, if I say SC is equal SF is equal to SC by SD. SD is x to the power of 4 minus y to the power of 4. And when you divide it by SD, which is x square minus y square, you know the answer is x to the power of 4. Okay, what I have done is x to the power of 4 minus y to the power of 4. I have divided it by x square plus y square. Automatically, it should be equal to x square minus y square. Now, this is what you get the output here. Okay, similarly, SG is equal to SB cube. If you try to say SB is x minus y, and therefore when you take the cube of that, okay, and you say expand this, the output of this is only this much. But when you use the word expand command, you know the formula x cube minus 3x square y plus 3xy square minus y cube will be given. Okay, so continuing with this for some more examples, if you say SI is equal to sine SA, SA is defined earlier as x plus y, and therefore sine of x plus y will be the output here. But when you say expand, then it will become cos x plus sine y plus cos y into sine y, cos A cos B plus sine A sine B. Similarly, if you say SK is equal to sine of SB, SB is x minus y, and you expand it, you would have got this as cos A cos B minus sine A sine B here. Okay, when you add these two, you know sine A plus B minus sine A minus B is equal to 2 sine A cos. This is what you would have got this particular format. So you need to expand this, otherwise it will give you only this format. Sine of A plus B plus sine of A minus B. Order is, of course, I have written s of sine of x minus y. You certainly know what is the output of this. And once you create this, you want to know what are the symbolic variables I have used in the expression Sm. Automatically, it will be displaying this. So sim variable is another command which tells you what are the symbolic variables that are available in the expression. Okay, earlier it was find sim command. I think they are phasing out with that command and using sim variable command. Next, if you have an expression, now already since you have defined x as a symbolic variable, if you say s is equal to x square plus x minus exponential x plus 3x plus 3, this is the expression that you are entering, and you get this expression. But if you say collect, remember the collect command collects the terms in the expression that are variables with the same power. Observe this. It collects and says coefficient of x cube, coefficient of x square, coefficient of x, and then the other one is 3e to the power of x. So that way you can try to look at what is the collect command also to represent it with coefficients of with the particular powers. Okay. Then even if you try to look at this way, here if you have an expression for g and you say collect coefficients of y, see this is an extra point that you need to observe. You simply just collect t, by default it will be x. Now you say collect the coefficient of y, you can see the coefficients of y are collected in that order, in that power. So therefore, what is important for you is to know how to define symbolic variables, and then these commands are listed out here. You know what is double command. You can convert it into numerical form. Find sim is not used being now. I think sim variable is a better command that you need to look into. And then collect command is used to collect terms with the same power. You know, expand command expands in two ways. Okay, it carries out the product in terms of including summation. It also uses trigonometric identities, exponential and logarithmic laws. Okay, there are some more command called factors, simplify, simple s, pretty s, and poly to sim command. So what is this pretty s command? If you observe this, pretty commands, he has created a, b, c, x as a symbolic variables, and then defining s is equal to square root of ax squared plus bx plus c. And when you give it like this, it will give you this way. But when you use the word pretty, remember the pretty command displays the symbolic expression in a format resembling the mathematical format in which the expressions are generally typed. As a person writing, I would have written it in like this. So by using the pretty command, you can just try to write it in the way we used to look at this expression. So another command is pretty command. And of course, factor command is there. I think I had missed it out in one of the examples here. Factor command. Somewhere I had written this. I think I might have just jumped it in the PPT. Okay, anyway, we'll just use it later if you can always do factors. Suppose you write x square minus y square. Y is equal to, you say a is equal to x square minus y square and say factor of that. It will clearly say it is the reverse of this. It will say x plus y into x minus y. X1 minus y will be factors of those things will be written. And also this is a simplify command. I think somewhere I missed it in this slide. Okay, I'll just add it up. Then let us try to look at using this in for some applications. So solving a system of equations, you can solve, solve equations, so many equations for these variables. There's the output that you would like to look into. So how do we use it? I've already shared this material. Just observe this part. See, he has defined sims x, y, t. Okay. S is equal to 10x plus 12y plus 16t. And he wants expression for xt and yt, means x and y in terms of t. Remember, the way he has numbered it is, named it is x and y in terms of t. That's the reason he has just put it as xt, yt. And you use the command called solve. Now, what are the equations you want to solve? Remember, you are looking at 2. Okay. And therefore, the expression s is one expression. The another expression is 5x minus y is equal to 13t. Remember, you need to put it in quote here and write the second equation if you have not defined it there earlier. And when you ask it to be solved, it is going to solve it in terms of xt will become 2t and yt will become minus 3t. That's how you can use it to its advantage. But if you have only this part, okay, the system, however, can be solved for different variables. And here, if you observe the same thing, solve s as well as this expression for y and t. So that means it will give you expression for t and y in terms of x, the other variable, because there are totally 3 variables in the equation, and you are asking for expression for t and y. Therefore, it will give you in terms of x. So it is tx and yx. Here it was xt and yt, means x in terms of t, y in terms of t. Now it has become t in terms of x and y in terms of x. So such expressions you can try to apply for a simple here. You observe there is an equation for a circle and there is a line. You want to know where a circle is there and a line is there. You want to know its point of intersection. You simply need to solve it for x and yc by using the symbolic expression x and y and are all symbolic expression. You have one equation here and the other equation is of the straight line. So when you say solve for it, automatically you will get
font ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಮಾಡಕ್ಕಾಗುತ್ತಾ?
ಹೌದಾ?
ಫಾಂಟ್
ಫಾಂಟ್ ನಾನು ಫುಲ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಟ್ಟಿದ್ದೀನಿ ಇಲ್ಲಿ.
ಸರ್ ಅದು PDF ಡಾಕ್ಯುಮೆಂಟ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಸರ್.
ಒಂದು ಕೆಲಸ ಮಾಡ್ತೀನಿ, ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಿ ನಾನು ಇವಾಗ ಐಪ್ಯಾಡ್ ಅಲ್ಲಿ ಅದು ಮಾಡಕ್ ಆಗ್ತಿಲ್ಲ, ಇಲ್ಲಿ ಏನು ಆಗ್ತಾ ಇಲ್ಲ ಅದು.
Sir, it's quite okay.
It's fine, sir. It's fine.
Now is it possible? It is increasing or decreasing?
Yeah, sir. It's quite visible.
Okay, I have one thing. I'm just going to commands only. And when it comes to the applications, I think if required, you let me know. I'll just zoom it out. Now, there are certain advantages of using the symbolic variables for differentiation also. You need to just define, of course, the terms in the s as symbols and just use the diff command. Automatically you can differentiate it, but there could be multivariables one. It could be a function, y could be a function of x and time. So you want it to be differentiated with respect to x by default, or you want it to be differentiated with respect to time. You have these two important format, diff of s and diff of s comma variable. So you can always say in with respect to what you can define it. And here, one more point that you need to look at is you can just try to use this differentiation for the nth derivative also. So when you say differentiate an expression for nth time, means second order d square s by dt square, or d square s by dx square, or d to the power of 4 y by dx to the power of 4, you can clearly say the expression has to differentiate with respect to a particular variable and what is the order of differentiation. So that way it becomes advantageous. So I've just taken these snapshots from the book on by Amos Gillard. Try to understand this, and you can also type it if you are interested. See, he defines x and y and t as sims. Okay, x and y and t as symbolic variable, and now he defines an expression s is equal to exponential of x to the power of 4. That is this one. See this term, e to the power of x to the power of 4. And when you said differentiation with respect to s, diff of s, automatically you will get the solution here, and that is this particular part. The answer is 4x cubed into e x to the power of 4, e to the power of x to the power of 4. That's how you can just differentiate it. Okay, and you can also directly write those expressions here and say differentiate this particular expression, which is 1 minus 4x to cube, and when you differentiate, you get this answer. Or you can give a differentiation of this. Remember here, r is a function of y and t. Y and t. When you say diff of r, the answer will be differentiate. Remember, the MATLAB will differentiate with respect to y. Okay, default symbolic value, and the answer is displayed here. Okay, but if you say, sorry, the answer is displayed here. If you say differentiate this expression with respect to t, if you want, then you are very specific that the differentiation of r should be done with respect to t, and therefore this is taken as a constant, and you get the differentiation, which is this particular part. And you want to differentiate this expression s to the second power, that is d square s by dy square. You would have got this as the answer. So it is an easy way to differentiate expressions using this symbolic mathematics. Same logic could be extended to integration. Okay, so instead of differentiation, we are looking at integration, and remember, it could be indefinite integrals or definite integrals. So when it comes to indefinite integration, remember, it's very simple, the same similar logic what we use for diff. Here it is int of s, so it can easily integrate the expression s with respect to the default variables, or you want to do it with respect to a particular variable, you have to say int of s with respect to var. Okay, so just see these expressions here. Sim of xyt. This, remember, never forget this part. Never put comma here. If I put in between one comma, the remaining terms are not defined as symbolic variables, and there'll be an error message. Suppose you say s is equal to 2 cos of x minus 6x, and you simply say int of s. Remember, this expression is integrated. This expression is integrated with respect to x, and you get, the answer, if you do it analytically, is 2 sine of x minus 3x square is displayed. Okay, and if you take directly, you can write the int of the expression inside itself. Then also you can get the output. And here, if you would like to look at an expression which involves y and t, and when you say integration r, integration will be done with respect to the default variable y. But if you say int of r comma t, then integration is done with respect to time. Remember, this is done with respect to time, and the answer displayed is this one. So this is the way you can do integration for this, and if this is for definite integration, then the extra thing that you need to give is integrate s with respect to the limits a and b. So a and b are the limits of integration. So you can observe this clearly here. When you say integrate sine y minus 5y squared dy with from 0 to pi, it is simply, you need to just never forget to define y as a symbolic variable, and then define, say, int of this particular expression, comma, space by lower limit and upper limit separated by comma, you'll get the relevant answer. So that way you are able to just carry out any integration with definite integration. And remember, sometimes it's not possible because the closed form answer may not exist. In that case, you will find explicit integral could not be found message from the MATLAB because it's not always possible to get. Now, I ran through this, and of course, I have pasted all these codes, and maybe I need to just do 2-3 slides might have deleted. But let us try to look at some applications with respect to this using symbolic variables. Now, I've taken a very basic exercise here to look into the application of symbolic variables. The first one is the bending resistance of a rectangular beam of width b and height h is proportional to beam's moment of inertia. That's fundamental from your SOM knowledge, defined by I is equal to bh cube by 12. Now, a rectangular beam is cut out of a cylindrical log of wood of radius capital R. Remember, the radius is capital R. Now, you need to determine b and h that will be cut such that the beam will have maximum moment of inertia. It's a very simple example. So when you have a log of wood of capital R radius, I can cut a rectangle of this size, or I can get a rectangle of some other size. Therefore, there are infinite possibilities of B and H. But I should cut it in such a way that I should be maximum because, bending resistance, M by I equals sigma by I. So you want maximum bending moment to be taken, I by C should be maximum, which is the section modulus. Therefore, we would like to look at optimizing the value of I in this particular exercise. Now, try to look at the equation that relates P and this is triangle. Consider this triangle. Is it not R square is equal to B square plus H by 2 whole square? So if you try to look at this, now what I need to look at is one is an independent variable. R is constant. It will not change because that's the diameter of the log of the wood, diameter of the log. So out of B and H, one is dependent in this combination, another one is independent. Suppose I take H as independent, then I can write an expression for B such that the different cross-section rectangles possible in this log of wood are obtained. So this expression is very, very important for this. Now, I need to write an expression for moment of inertia because I want to maximize I, extremize I. Therefore, from fundamentals, I is equal to bh cube by 12. And remember, I have made the B as a dependent variable. Therefore, I'm writing this expression in terms of H. Okay. So what is that I need to do is, if I want to have a maximum value of I, then I need to just say di by dh, differentiation of moment of inertia with respect to h, should be equated to 0. Either it will be maxima or minima. So you get the maxima condition, and that will give you what is the value of h that you should take to keep the I maximum. And based on that value of h, you can get B. Therefore, I just pasted this program and the corresponding output. Those who would I would like to give some time. I put the code in the WhatsApp group itself. So you can just try to look into this. What is that we did in this particular problem? You just paste this code. I told you clear and clear all is very, very important. Now in this problem, we have to define B, H, and R as symbolic variables. So sims B space H space R, no comma in between. Now, I have written an expression for B in terms of this part. B is equal to root of 4R square minus H square. So, B is equal to square root of 4R square minus H square. And then I know I is equal to BH cube by 12. Therefore, if I say what is I, you will get the output as, I put a semicolon here, therefore the output is not coming. It will replace B in terms of this expression and give you the value of I. Now, I need to differentiate this expression with respect to H. Therefore, I'll say first differentiation is differentiation of I with respect to H, and you get an expression. Okay, better you can, well, just running this program, you better remove this semicolon here and here. Okay, you will get this equation. And now that should be equated to 0. So that we have called HS equals solve this ID, the equation that you have obtained for H, and you would have got these three values. So try this example. Remember, you can remove the semicolon to see what are the intermediate values that you're going to get. And when you solve ID, this ID, which is the equation that your expression that you got by differentiating I with respect to H, you would have got three values. Now, minima is here, or the negative value is not, it's a trivial solution, means it is not of practical importance because you cannot have height to be negative. Therefore, you filter out this one. So this is removed from the solution. 0 is not the solution, but it is a mathematical solution, but not an engineering solution. It is a trivial solution. Only non-trivial solution that I have in this is this one. Therefore, you will notice that it is cube root 3 to the power of half into R is the optimum value of HS. Okay, so 1.73 times the radius, if you take it, you'll get the maximum value of the optimum value of HS. Now, that HS, this value of root 3R has to be substituted in B. Okay, and to substitute that value in B is this expression. Remember, in that I want you to replace H. Hello. You need to replace. Okay. You need to replace H in terms of HS so that you get the optimum value of B also. Okay. But only thing that you need to observe here is there were three outputs. Out of these three output, the second output HS of 2 is the acceptable solution. Therefore, you should say substitute HS of 2 here and you get this expression. Remember, this expression is nothing but R itself. R to the power of R squared to the power of half is R itself. So the optimum value of beam that you need to get here is from this log of wood. The optimum value of this that you are going to get is a rectangle whose width is equal to radius and whose depth is equal to root 3 times radius. This will be the optimum value that you need to look at. This. So this obviously gives the optimum value of B and H. So it's a very simple exercise, but just because we are using this symbolic approach to get solution to this problem, I took this case. Any people who would like to run this program, and are you getting any solution, or you can try this later also. Okay. Now let's try to go to slightly different problem on kinematics of that is projectile problem. See this problem here. He says a projectile is fired at a speed of 210 meters per second. Okay. The projectile is intended to hit a target which is 2,600 meters away and 350 meters above the firing point. Now, if you want to find out the path of the projectile and the angle at which has to be, that is the angle at which has to be fired with this particular input velocity, and you want to trace the path of the projectile, first of all, I should do from fundamentals of engineering mechanics, derive the equation that has to be solved, because I'm going to use this for solving this solve command. So derive the equation that has to be solved in order to determine the angle theta such that the projectile will hit the target. Then use MATLAB to solve the equation derived in part A. And for the angle determined in part B, use EZ plot. Of course, now I just used F plot command to make the plot of the projectile's trajectory. It is easy to use F plot here because Z plot is in the symbolic part. So let us try to look at the first part A. You have to derive the equation. So look at this part here. See, the projectile is fired with a velocity of 210 meters per second at some angle theta. Okay. And it has to hit a target which is 2,600 meters in X direction, and in Y direction it is 350 meters. Okay. So what you need to do now is just use this fundamental expressions. Once you have to apply the equations that you have learned in vertical direction and in horizontal direction. So if u0 is the initial velocity, u0 cos theta, remember, is the horizontal component or the x component. u0x is the horizontal component, and that horizontal component is not subjected to any acceleration. Therefore, it is of uniform velocity. Got it? And if you look at the vertical component, u0y, it is subjected to acceleration due to gravity. And therefore, you should, for vertical component, you need to bring in g. Okay. So let us try to apply this information. Remember, horizontal direction of velocity is constant. And you know the distance traveled x is equal to horizontal component of the velocity into time taken. Therefore, time taken t is nothing but distance traveled by velocity. That velocity in x direction is constant. So you have an expression for t to reach that distance x. But in the vertical position, if you take the vertical component, then y is equal to ut minus half gt square is the expression. But that should be applied for the vertical component. Therefore, it is u0y t minus half gt square. Therefore, this y is u0 t minus half gt square. Now you replace the time that you have got here from equation 1 as x by u0 x. So this becomes x by u0 x. u0 x means u0 cos theta minus half gt square. So we are making this equation in terms of theta, and we have eliminated time taken here. So by simplification, u0 will cancel out. You have this as x tan theta minus half g into x divided by u0 cos theta whole square. So if you can solve this equation using the solve command used in symbolic maths, you can get the value. You can solve this equation for theta and find out the angle. Okay, that's the expression. So if you try to look at the code, it is hardly a few lines. We have defined th and t as the symbolic variables. Remember, there's a space here. It's not one word. It is th is one string and t is the another one. So th and t are symbolic variables. And you need to just say, solve this equation. Solve this equation 2. What is this equation 2? Solve 2600. Okay, because x is 2600. You can replace it directly. X is 2600 into tan theta minus half is 0.5, g is 9.81 into x is 2600 divided by u0 cos theta. u0 is 210 cos theta whole square. And remember, this should be equal to 350. Is it not? The distance traveled in y direction. So the final y value is this one. So this is 350. Therefore, when you have this expression to be substituted, remember this is given as 350. You can write the equation minus 350, and if you don't, automatically it will equate it to 0 because you have not put equal sign in this. Therefore, you should know why you have got 350 and minus sign here. And when you say solve for this, it will solve this complex equation very easily, and you get the solution to the problem. But the problem is they are all symbolic variables. You will not be able to interpret it. By taking double, I told you double is to get its numerical form. By taking double of this angle, you get the numerical values which can be used for your interpretation. But the thing is, it is better to visualize this angle in terms of degrees rather than radians. Therefore, we already multiplied it by 180 by pi also, and therefore angle in degrees I can directly obtain. When you obtain this angle in degrees and just see the length of this chord, hardly so much. Automatically, given this value of x equals 2600, velocity v naught as 210, it's u naught, g is 9.81, you get 4 solutions for angle degrees. Remember, I've converted into degrees. Actually, the equation solves for radians, and later on I've converted. There are 4 values. It's a vector of 4 values. Now, what are the values which is not making any physical significance in the problem is you cannot fire it below ground. So minus 108 degree and minus 153 degrees are not the practical solutions, because I told you it is going down, and that is not the path of the projectile. So you can easily filter out these two values. It's not acceptable. Okay, and therefore I'm left out only with this. So once you know the output, you can need to take only the 2 values at which I need to fire the projectile. So one is 26 degree, the other one is 71 degrees. So you can easily get it. Therefore, you define the 2 angles. Theta 1 angle at which it can be fired is angle degree of 4. How did I get this 4? Is only because of this output. I noticed that this is the first angle that I can take it as angle degree of 4. And the second theta 2 is angle degree of 3. So 2 values practically accepted. Those are the 2 possible solutions to this problem. Now, once I know the angle at which these can be fired, I can also try to find out the path. But remember, they are reaching the same target. One is fired at an angle of 26 degrees. The other one is fired at an angle of 71 degrees. Automatically, the time traveled will be different. So if you want to calculate the time travel here, you just try to look at the x mass divided by time is given by what? Horizontal distance covered by velocity. Velocity is known to you. V naught cos d. We have defined V naught as the velocity here and not U naught. By deriving equation, I put it as U naught. Now it is V naught in the program. So by putting this, you can find out what is the time, and it comes to be 13.8121 seconds. And if you calculate the other possible value by putting theta 2, you get 38.7235 degrees. Okay. Now I need to plot it. So you need to just get this as a function of time. Okay, at various positions. So shall we define this as at any distance covered here? Remember, this is distance, but remember, this is a distance. This is x and this is y. But as a function of time, at any time t, if you want to know, the distance covered is x1 and the corresponding vertical height is y1 of the projectile. So this is x1, this distance is x1, and this is y1. Like that, various points can be obtained, okay, in terms of t. Similarly, you substitute the second angle theta 2. You get expressions for x2 and y2. Now, my x-axis is same for both, but I'm plotting it in terms of time, which is implicit in this. So here, the first curve is having a time of t1. Therefore, you can use the fplot command. You can also try if you want with zplot. Fplot is plotting x1, y1 for various values of time. Remember, fplot is a function plot for various values of x and corresponding y1, dependent and independent in this graph, starting from 0 to t1. T1 is what? The time taken by the projectile when it is fired at the first angle. That is 26 degrees. And similarly, just say hold on, because otherwise when you plot the next curve, automatically the first one will be erased. So if you don't put hold on command, say hold on the same graph, you plot x2, y2 from 0 to t2. Remember, if we are saying from 0 to t2 or 0 to t1, that is automatically taken care of. and you get the corresponding x and y, and you get these two plotted here. You can see this curve here. This is blue curve, and this one is the second possible path. Okay. And one reaches in 13.81 seconds. The angle to be fired here for this projectile is the tangent here, and that angle is going to be around 26 degrees. And this one is fired at an angle of 71.35 degrees. This takes time of only 13.81 in seconds, whereas this one will take 38.72 seconds. So that way, you can just try to look at this symbolic expressions for application of symbolic expression in solving these problems of projectile. Of course, you have direct problems also on projectile, which you can look into without solving this equation. Directly, the values are known at different time, and you can just plot the path of projectile. Any doubt in these two problems? Hello? Devaj, I'm audible?
No, sir. No, sir. You can carry on.
Okay, please continue, sir. Please continue.
Okay.
You're
So
audible.
I'm just trying to look at this slider crank mechanism as another kinematics example. But I would like to just revise this basics, which was done by all my previous colleagues in different sessions. It's very important for you to look at element by element operations before we take up the next exercise on kinematics of slider crank mechanism. And we are using this for very specific purpose. See, when I say there is a vector of, say, x is equal to 3, 5, 7, say 3, and y is equal to 5, 8, and 9. And when I say x plus y, what you are doing is 3 plus 5 is equal to 8, 8 plus 5 is equal to 13, and 9 plus 7 is equal to 16. Automatically, it will do element by element operation. So addition or subtraction is not required. Automatically, it's defined. But when you want to define multiplication, x is a size, it's a vector of 1 row, 3 column. Y is also 1 row into 3 column. So if you say x into y, it is not defined because 1 by 3 into 1 by 3 is not defined. Okay, and therefore, that's very, very important. One error message will come if you try to write it like that. But if I want to take corresponding terms to be multiplied or divided or taken power, or when I say divided, it could be right division or left division, you need to be very careful. Element by element operation, you need to apply. Therefore, there's a dot operator you can see in all this example. Dot, whenever multiplication, exponentiation, and division are there, dot operators are present. For example, if you just try to do x is defined as a vector starting from one starting element, 10 is the ending element, and with an incremental value of 1, and I say execute it in command window, I am going to get all these terms. Okay, I'm going to get this 1 to 10 numbers. Now, if I say x to the power of half, that means you are trying to multiply x vector with x vector. X vector is 1 by 3, and again x vector is 1 by 3. It is not defined. You will get an error message. Okay, but you want to do it element by element operation. Remember, you need to just give this very important thing is the dot operator here. X is a vector. Each element of that has to be squared. For example, when I say x dot square, automatically 1 square will become 1, 2 square will become 4, 3 square will become 9, 4 square will become 16. Element by element is being attended. And therefore, this is very, very important for you to understand this element by element operation. Remember, multiplication, exponentiation, and division, you need to take care of this. The second point I would like to discuss here is this putting multiple plots. Anyway, you have done the exercises on plotting. Same plot, number of exercises, number of graphs you want to do, you can use hold on commands, or in the single line command itself, you could have plotted x versus y, x1, x versus y1, x versus y2, like that you could have done. But here, I would like you to just extend it to another concept called subplot. In subplot, what you need to define is, you say, I want so many graphs. Each is different. Its x-axis, y-axis could be different. So in that case, I can't plot it on the same thing. See, if I ask you to plot load versus deflection diagram or stress versus strain diagram, they are to a different scale, but the units are not same. You can't plot it in the same graph. If you want, you could have taken for subplot. What you have to do is you have to define the subplot by how many subplots you want here. So it is defined by M and N. Observe this code, subplot command, subplot M, N, and P. This is very, very important. So when it's defined subplot M and N, that means there are M rows, row 1, row 2, row 3. And N stands for columns. N stands for column 1, column 2. If you say N is equal to 2 and M is equal to 3, then 3 rows, 2 columns will be the number of graphs that you are going to plot it. Second thing is the naming are done row wise. Okay, so this will become graph 1, and that is P. You want to plot this graph, you should say subplot M3, 2 in this graph, and 1P should take a value of 1. Then if you want to plot it here, it should take a value of 2. Then you should come to the next row. 3 is this graph, 4 is this graph, 5 is this graph, 6 is this graph. Got that point? So 1, 2, 3, 4, and 5, 6. Okay. That's an important thing. Now let us take a look into this example of slider crank mechanism. And I'm just trying to look at some very basic equations that you need to refer to. Take an example. I think I deleted something here. So it is an example of slider crank mechanism. It is example of slider crank mechanism. So if you have studied, all of you have studied this fundamental subject. So if R is the radius of crank and L is the length of the connecting rod, and if omega is the speed at which the angular velocity in terms of radians per second, if you are given RPM in the program, you just say multiply by 2 pi n by 60, you get omega. So omega is an input, R is an input, L is an input in this particular analysis problem. So trying to look at the equations for analytical approach. If I take this as the origin, so this is 0 for me, x is 0, y is 0. Then at any given instant, x can be written as r cos theta plus L cos phi. The theta is the angle made here and phi is the angle made by the connecting rod with the line of stroke. So when you do this part, you know the horizontal component of the crank is r cos theta and the horizontal component of the connecting rod is L cos phi. So at any point of time, if I want to write an equation for x, it should be r cos theta plus L cos phi. But the thing is, phi is not independent. It depends on theta. Therefore, you convert this expression in terms of theta. And what's the equation that you have between these two? You know the vertical height here is r sin theta, and that's also equal to L sin phi. So you have a very simple equation now. R sin theta is equal to L sin phi. Therefore, sin phi is equal to sin theta divided by L by R, and that becomes sin theta divided by N, where N is taken as L by R. Not to be confused with RPM. This ratio is L by R, and those of you who have started a lot of balancing problem, primary inertia forces is F is equal to MA. Acceleration obviously involves sin theta plus sin 2 theta by N. That N is L by R there and not RP. Omega is separately taken care of. So you can therefore rewrite this equation, replace cos phi here, replace this cos phi in terms of sin phi and then sin theta. So cos phi is 1 minus sin square phi to the power of half. And you know sin phi is sin theta by N. Therefore, it becomes 1 minus sin square theta by N square to the power of half. And N is L by R. Therefore, if you replace N as L by R, you get the simple expression for the position of the piston. So this is an important equation. Let me call this as equation 1 for plotting as a function of theta. So you have x is equal to r cos theta plus L square minus r square sin square theta to the power of half. So the displacement is in two components, d1 and d2. Okay, but in the program, for ease of avoiding repetitive typing, I can always take this value L square minus r square sin square theta as d2s. Okay, and then if I want d2, I will have to raise it to the power of half. So that the same thing is reflected in your velocity and acceleration equation. So instead of writing in your program each time L square minus r square sin square theta, you define L square minus r square sin square theta as d2s and do it. Therefore, remember, when you code it, I want you to observe this important point. When you code it here, remember you have taken theta in degrees between 0 to 360 degrees, 73 values. That means I have divided the crank positions at every 5 degree by taking 73 terms, 72 division or 73 terms, including of 0 to 360, it is 73. And I told you d2s is L square minus r square sin square theta. But if you want, you can do it in degrees. If you want, you can do it in radians. I have taken it in degrees here. But a more important thing is, remember, when you calculate it for every 5 degree, 0 degree, you want to calculate d2s. Then again at 5 degree, you have to calculate d2s. 10 degree, you have to calculate. That means it is element by element. I need to find out d2s. Therefore, it's very important for you to use this dot operator. Dot to the power of square. Okay. So anytime, whenever you have a vector with vector multiplication or division or exponentiation, remember dot operator is a must to do element by element operation. Therefore, in my program, I have just typed it as x is equal to r cos theta. This I put it as degrees plus square root of, this is not taken in d2s. So square root of d2s. So this will do it in the program part. Now, if I want to go for velocity, it's not very simple for you in the sense I'm not deriving the steps. Velocity is nothing but dx by dt. But my expression for x is in terms of theta. So use chain rule for partial derivative. X by d theta into d theta. Point. Velocity is omega into dx by d theta when we go to symbolic variables. And now we should differentiate on a paper and do all the expansions. You will be getting this equation to be coded in my program. So this is my second equation. And we carefully observe the program here. R omega sin theta. R omega sin theta. I've called omega as angular velocity in the program. Minus r square. Remember, r is just a scalar quantity. Omega is angular velocity. Sin 2 theta. Divided by not a scalar. It is a vector here. Theta is coming here. That's also another vector. Therefore, a very important thing is this dot operator slash division, right division. 2 square t d2s. You got that point? Because this is also a vector and this is also a vector, I need to use this dot operator. But if I go to symbolic mathematics, there is no need for me to write this equation at all. I can directly take it as omega into diff of x with respect to theta. So just observe this equation. I'm just trying to correct this here. Vs is equal to diff of xs. I call this in program x of slider. Differentiate with respect to theta in radians. I cannot differentiate with respect to degrees. I'm doing it in radians, but never forget to multiply this omega part, which is angular velocity. That's an extra term that you need to be careful. So I have this equation 2, which gives me analytical solution, and I can also use directly symbolic variable without writing this analytical solution and get solution to this problem. Further, if you want x double dot, acceleration of piston, again, I want differentiation of time, differentiation of velocity with respect to time. Again, it's a function of theta. So again, if you observe, I'm going to get this one as one more omega will come into picture into dx dot by d theta. So you have already an expression for x dot, and you know how much time it takes for you to differentiate and get this final expression for acceleration of piston. Okay, it's a time-consuming activity. But if you had used symbolic variable, you simply have to give the expression for position, a very simple expression. Differentiate with respect to radian and multiply it by omega, you get velocity. Differentiate that velocity with respect to omega, time, theta and radians, and never forget to multiply it by angular velocity in radians, you get the acceleration. So this is far easier route, hardly 4 or 5 lines command for you to do the velocity acceleration analysis. But if you want to compare it with your analytical solution, you need to just write this expression. So just look at this part here. Minus r omega square cos theta, minus r angular velocity square cos in degrees. Okay. It depends whether you would like to do it in degrees or radians. D stands for degrees combination. You have to be careful. If you oversight, you forget to write D cos D, and you put theta in degrees, your answers will be a junk value. Okay. Minus 4r square omega square cos 2 theta. Now it has become a vector, and you are multiplying it by another vector because this is sin square theta is a vector. It has a value of sin theta for every 5 degree. Therefore, a dot operator here into D2S, because this is D2S for us. There's no need for you to type it again, L square minus R square. And then in the numerator, R square omega sin 2 theta whole square. R square omega sin 2 theta whole square. See, remember, this is a dot operator because sin 2 theta is again a vector, and you have to take dot operator here. Angular velocity can be outside. But remember, you have to take a, sorry, I made a mistake here. This is just there is no dot operator as far as this is concerned. But the entire thing, after closing the bracket here for the second term, you need to divide it by another vectorial quantity. Therefore, this dot operator is coming here. Got it? I made a mistake. This dot operator here is because this numerator is divided by denominator. So divided by with the dot operator, element by element. 4, this is D2S to the power of 3 by 2. This is if you do it from analytical, but I told you through symbolic, you can just try to work it out. Now, I've sent you the code in Word file itself. Let us try to understand the code part here. Okay. Here, we have tried to make a general program, but now for you to each time go on entering the length of the crank, connecting rod length, and the angular velocity, all those things, it's time consuming. So when you want to debug the program, don't try to give input, directly give the input for a specific benchmark case that you don't give. So in a textbook, this for 550 RPM and the radius of 0.125 meters and the connecting rod length of 0.5, there's a solution available. So we therefore, to check whether our program is running correctly or not, I have taken this value. Once you have debugged the program and you know it is proven, you can just try to give a general these statements, remove the comment statement, and ask the operator to give whatever length of connecting rod, crank radius, and the RPM. Got it? Therefore, here I just made this comment statement, and we have given, remember, RPM is 550, radius is 0.125, L is equal to 0.5, everything is in meters. Now, it's my duty to get omega, because we are not written the equation in terms of RPM. So therefore, omega is 2 pi n by 60. So you can calculate omega here. Okay, you can calculate omega here. So this step gives you the angular velocity. Now, I need to create a vector of theta, either in radians or degrees. So from 0 to IDC position to back to ODC 180 degree plus back to IDC another 180, so 360 degrees. You can use linspace command or the arithmetic progression approach. So 0 to 360 by taking 73 values, don't type it as 72. If you type it 72, there's nothing wrong, but it is not in terms of 5 degree because you are doing 71 division and not 72 division. By writing 73 here, you are making it as 72 division, means each is 5 degree. Now I told you D2S is the first part, only this portion without the half. So D2S is defined here. Okay, D2S defined here. Now it's very easy for me to write an expression for x, r cos theta plus D2S to the power of half. So x is now r cos theta plus square root of D2S. If you want to differentiate this, if you differentiate, you will get velocity. So x differentiated means velocity. You can use your own variable name. You can say v, you can say velocity of piston or velocity of slater, like that. You can use your own. X differentiated is nothing but this expression. I told you minus r angular velocity into sine theta in degrees minus r square angular velocity sine 2 theta, but now it is to be divided by a vector quantity, and therefore don't forget this dot operator and get xt. In the next line, if you differentiate it further, you know that this is the expression that we have got for acceleration. Okay, and when you take this value, this is a vector, no dot operator in the first part, minus sign here. This entire thing, remember, there has to be a dot operator here because this is cos 2 theta and this is here. So at cos 2 theta, you can find there's a dot operator here, and the denominator is, the numerator is a vector and denominator is a vector, element by element operation. So dot operator here, and this itself is getting squared here, sine 2 theta whole square, and therefore a dot operator here. Now once you do this part and try to execute only the analytical part, I know that I have to generate 6 graphs. And the first graph is for position. So how do I define it in the form of a table? I want to write left table is for analytical, right side is for symbolic. So left one means 3 rows, 2 columns is what I'm defining as subplot. In that the first plot is plot of your x-axis is what? X-axis is theta and y-axis is displacement x. Don't get confused. Don't write x here. Your x in this program, displacement of piston, is the dependent variable. Independent means x-axis is theta in degrees and y-axis is x. And if you say grid, you know you can get all the grids on here. You can see the output, there is going to be grids. X label, you can say, observe this code here. X label, if you simply write theta, it will type theta in the X label. But by putting reverse slash, you get the Greek symbol, theta. So you get the symbol theta by putting slash. If you say slash tau, it will become tau symbol. If you say slash gamma, gamma symbol will come. Like that, you can always get any of the Greek symbols that you want to put it. So, and you can also give the Y label title, and Y label title is now position. Remember, it gives me the position of the piston in meters. And you can place the text. You can play with this. When you go to graph, either at a case by case, I can open the graph window. There I can edit so many things. But that could be taken and pasted to your notes or your report, whatever you want. But when you run the program again, all those settings will change. It will give back the same run that you started with. Therefore, it is always better to write in your program how many tick marks you want, what is the title you want, exact positions. Anyway, text is given here. I want a text of Slater crank mechanism, which you can see it in the output here. And I'm going to give the title here. Okay, title is Slater crank mechanism analytical. Analytical is here, sorry. This is analytical. And the limit I want, otherwise the graph will plot to 400 degrees. I know exactly 360 degrees, one round. And you can also control the tick mark frequency also. Otherwise, it will go give it in terms of tens if you want, and it will show 350 here, and those graph is to a length of 360. So remember, I'm using this command called x limit, means x starting and ending value 360 degree. It should exactly terminate. And axis tight is another command which you can try to squeeze it within the data, exactly fitting the data. And you can control the tick marks here. Use this command for controlling the tick marks. From 0 to 360 degree, every 60 degree, I want one tick mark here. You can see. Okay. And then I've got this graph. But now I want the velocity graph by analytical method. So what is the position here? Remember, 3 rows. I told you it will go like this. 1, 2, 3, 4, 5, 6. Therefore, this is for displacement. Now 3 is for velocity. Therefore, you should say subplot 3, 2, 3. Plot your x-axis is the crank position theta. Y-axis is the velocity of piston x, that is x differentiated. And you can switch on the grid, put the title of x-axis, put the title for y-axis, clearly say what are the units. And you can put the limits. Otherwise, I told you the graph will go for a different length. And you can control the ticks so that you will get this graph. Remember, it is subplot 1 and subplot 3. And then you can also go for acceleration. And what should be that one? Subplot 5. So the acceleration here is subplot 5. Therefore, you need to take it as subplot 3, 2, 5. Plot x-axis is theta in degrees. Y-axis is x differentiated twice, means acceleration. And then grid on, give the title, clearly say this is the unit, and you can see the output here. You will get this graph. Okay. Next, an important thing that you need to know is, at the outset, I know whether I have done correctly or not, because the maximum value of x maximum is what? When theta is equal to 0 degree, it is x plus L. So you know what is x and L in this program. Okay, you have taken R plus L, sorry, 0.125 and 0.5. So it is 0.625. Therefore, at the outset, you should notice that in the graph here, position graph, it is 0.625. I guess at least you have done it correctly. And minimum is what? X minimum is when it takes to 180 degree, X minimum is L minus R. And that is what you get here. So the graph is plotted from that range to X minima to X maxima. Because I want, you can do it from 0 to that. It doesn't serve any purpose. Then you can also try to find out what is the value of maximum displacement and so on. So, you know, X is a vector. It has got series of displacement values at every 5 degree. Now you say, which is the maximum value? It will tell what's the maximum value. So you can use this command called max of X. You get the maximum value. But I want to know at what angle of theta is that maximum. Okay, at what angle of theta is that maximum. Okay, for that purpose, what you need to do is, you can say the output of maximum of X is X max and corresponding location I. Means at what vector location is that value. And at that value of I, what is theta? If you say, you will get both X max and theta max, and that's what you get here. Maximum displacement happens when theta is equal to 0 degree is the output. Just 1 minute. Okay, so you can easily find out the maximum value of X, not only that, and the location. Similar to problem what Professor Narari solved it also, you can find out at what location the cable value changes from tension to compression. Okay, and similarly, you can get maximum displacement. You can also get maximum velocity. So maximum of XD will give me the maximum velocity. Remember, you may not be actually finding the maximum velocity because you have done it at every 5 degree. The maximum velocity that you get could be here, it says at 285 degree. Remember, actually it happens somewhere at 85 degree and 180 plus theta plus 180. Where it happens, we have done calculation only at 5 degrees. But your answer may be between 85 to 90. In such cases, it is better you increase the number of divisions that you want to look at. Okay, and you get XD. Remember, if I simply say V max is equal to max of XD, you get maximum velocity, but you'll not be able to tell what is the angle at which it is happening. And you want to know the angle at which it's happening, you should get 2 output values, not only velocity, at what value of I, means Is it the 56th element in the velocity vector, or is it 95th element? So once you know it is the 95th element, you can say what is the corresponding 95th element in your theta vector, and that will give me that it happens at 285 degrees. Remember, it has already happened at 285 minus 180 degree, because there are two possibilities in the mirror image of the slider time mechanisms with respect to the line of stroke. Similarly, you can always find out the acceleration also, and you get the acceleration happens at the extreme position because the direction changes and its value is there. Now, why we required the subplot was velocity is in terms of meters per second, displacement is in terms of meters, and acceleration is in terms of meters per second square. Therefore, we have all these three graphs coming into picture, one below the other. Okay, so there. Now, instead of doing such a big equation, you could have easily solved this with symbolic variables. So what you need to do with symbolic variables is, now I need to do it with respect to radians in symbolic differentiation. So I have defined xx and th are extra value add, extra name, because th is already used there, x is already used there, that we are not defined as symbols. So thr and xs are symbols, and d2 we have already used it, d2s we have used it, therefore d2s is now this one. This is now a symbolic expression. Now xs is r cos theta plus square root of d2s is known to you. Remember, I already taken square root here. So xs is known to you. What is that? Simply you need to know is differentiate this xs. If I want vs, it is dxs with respect to dt. But xs is in terms of theta. Therefore, you would have made it as d by dxs is one word by d theta into d theta by dt. Therefore, when you say differentiate this xs with respect to theta, I need to multiply it by omega to get vs. Therefore, you can observe that omega is multiplied here. Simply just say vs is equal to diff of xs radians, and then acceleration is diff of vs with respect to theta r. And again, you will get angular velocity. Now, what are the graph positions I need to plot? I told you 1, 2, 3, 4, 5, 6. Now, these are all analytical. So 2, 4, 6. So just say a plot, and you want to plot it from 0 to 2 pi, because radians is degrees is difficult here. So subplot 2 for displacement from 0 to 2 pi is the x-axis, and xs is the value. Then if you want it for velocity, it is subplot 4. That is, you will get it in this position. And again, the same thing, but it is vs now. And you put the titles. And if you try to look at the subplot, the last one, it is 6, and it is for acceleration. You plot acceleration. So when you do this, you get this output. Now we have just did it to compare each one of these values. But of course, this is in degrees and this is in radians. But look at the values of displacements. Look at the value of velocities. Okay, it should be same. Otherwise, I've done something wrong here. Here, some power is missing to the power of 1. That's all. Into 1 is missing. Probably I have not pasted the graph correctly, but the values are coming exactly. Okay, this is while moving the graph, the tick indicators has moved a bit. I can just run it and show it. Okay, these are the things that I wanted you to look into, and of course I have used Amos Kilot, especially I have just taken few directly, and that's what I would like to cover here. Any questions? I know it has become monotonous because I didn't go for package. Want to show any of the programs we run? I can show. There's a program on slider gun mechanism. So I told you I've just commented the input statements, and if you run it for this values of the RPM, I'm busy. It's taking 2-3 minutes to run. Hello.
Yes, sir. Yes, sir. Please. Sir, ಬಂದು ಹೊರಟೋಯ್ತು ಸ್ಕ್ರೀನ್ ಅಷ್ಟೇ. Okay, sir.
ಅದೇನಾಯ್ತಂದ್ರೆ
Yeah,
ಡಿಸ್ಟರ್ಬೆನ್ಸ್
we'll
ಇದೆ
wind
ಎರಡು
up,
ಅರ್ಥ
sir.
ಇಟ್ಕೊಂಡ್ರೆ ಸಿಸ್ಟಮ್
Yes,
ಮೂರ್
sir, yes,
ಸರ್ಕಲ್
sir.
ಅದೇ ತರ ಕಾಣಿಸ್ತಾ ಇದೆ ಇವಾಗ
ಇಲ್ಲ ಸರ್, ಈಗೇನು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಸರ್. ಈಗೇನು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. ಐ ಥಿಂಕ್ ಏನೋ
See, this program is of course written by Professor Santosh, and if I run it, obviously I can just check the convergence value. I can just change the number of elements and get the plot. Okay, the plot is also not coming. ಇಲ್ಲಿ ನಂಗೆ ಪ್ಲಾಟ್ ಬರ್ತಾ ಇದೆ FEM ಬಟ್ ಅಲ್ಲಿ ಬರ್ತಿಲ್ಲ. I can just share this codes. FEM codes ಎಲ್ಲ ಬೇಕಾದ್ರೆ I can just share it.
Sure, sir. Please.
FEM ಇದೆ ಆದ್ಮೇಲೆ ಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಕೆಲವು some more sound problems are there. I think values are coming here. You can see that command for TikTok, how much time it took by using the TikTok command. It is showing that it is taking 3.97 seconds, and the number of elements I have taken here is this is a simple problem of cantilever beam with end load, and the entry here we have said the number of elements is 50 elements are taken here. So this is, if once you run it on your system, you can get the graphs. If you start with 1 element, 2 element, 4 element, you can show how convergence is achieved. Like that, you have got some more problems of heat transfer. You can get it with FEM, heat transfer or structures problem. So this is heat transfer problem with elimination approach of handling boundary condition. Here, but we are not doing any fundamental modeling here. It's just element by element calculation, how to assemble all the global, get the global stiffness matrix, and when I run it, it gives me all the important outputs, and you can also see the answers by both the methods. See, these are the things that we have got it as an output. Those who have worked it out elementary problem, first thermal conductivity matrix K1, K2, K3, global conductivity matrix, and then how do you apply elimination approach of handling boundary condition, and then run this program. You get these are the answers that you are going to get. Global temperatures, the same thing is compared with ANSYS values and validated. Like that, you can do it with penalty approach also. Only thing is the size of the matrix gets reduced. So the same problem we have done it with the penalty approach also, and I can share all these codes. Heat transfer penalty approach. Now here you should pick up the maximum value. See the command used here. C is equal to maximum of the global stiffness matrix. That will be the value of C. You need to add it to the respective diagonal elements, and when you run it, I should get the same values. You try to compare both the approaches to just show that whatever they try to do it manually could be coded. So these programs on FEM and some more programs, of course, most of them are being done by our faculty members, including Mr. Devaraj, Nalavi, Trupti, Santosh. All of them have contributed to these programs. I just put this in a directory, that's all here. And you can use it for several of these things. SFD BMD, some problems, more circle 3D also. And someone was asking whether it can be hatched internally. So if you are trying to plot a 3D more circle, all the 3 circles will come, and you would like to look at the feasible regions. Of course, it's not, the graphics display is not coming here. And few slides I missed it out. Probably I just took it in Word file. I have given the codes there and output, but I have not taken it to PPT and made a PDF.